So welcome students. So in this question you have two curves y square is equal to 4x and x square is equal to 4y. There are two parabolas, one horizontal and one vertical. It's given that they intersect at the point 4, 4 and from 4, 4 you have drawn lines parallel to the coordinate axis. So now you can see that you get three areas S1, S2, S3. You're asked to find the ratio of these areas. So how do we get this? So first let us find the area S3. S3 can be very easily found by integration. S3 is equal to integration from 0 to 4, right? 0 to 4. If you integrate this curve, you get S3. What is this curve? Y is equal to x square by 4. So x square by 4 dx. X square by 4 dx. That is equal to 1 by 4 times x cube by 3 from 0 to 4. That is equal to 4 cube by 4 times 3, that is equal to 16 by 3 square units. So the value of S3 is 16 by 3. Now, let us find the value of S2 plus S3. So S2 plus S3. So let us find the area bounded by the curve y square is equal to 4x and x-axis between 0 to 4. So if I find the area bounded by this curve and x-axis, I'll get both S2 and S3. So S2 plus S3 is equal to integration from 0 to 4. Integration from 0 to 4. This curve is 2 root x dx, right? Because y square is equal to 4x. So y is equal to 2 root x. So 2 root x dx is equal to 2 times integration of root x is x power 3 by 2 by 3 by 2 from 0 to 4. That is equal to 4 by 3 times 4 power 3 by 2 is 8. That is equal to 32 by 3. 32 by 3. So S2 plus S3 is 32 by 3. So S3 is already known as 16 by 3. So S2 is equal to 32 by 3 minus S3 is 16 by 3. That is equal to 16 by 3. So S3 is 16 by 3, S2 is also 16 by 3. Now, we know that S1 plus S2 plus S3 is equal to, if I add all these areas, we know that it is a square with dimensions 4 and 4. So the total has to be equal to 16. So S1 is equal to 16 minus S2 plus S3 is 32 by 3. That is equal to 48 minus 32. Again 16 by 3. So all the three areas are 16 by 3s. So the ratio of these areas is 1:1:1. Thank you.